talk about are complements, and an illustration of this is the events for rolling a 1 and for not rolling a 1 are complements. And the sum of the probabilities for any two complementary events is always 1. So if you think about it, the probability of rolling a 1 on a die is 1 out of 6. The probability of not rolling a 1 is 5 out of 6. There are 5 numbers that are not 1 out of the 6. And if I add those together, notice we have our common denominator, so we can just add numerators. I would get 6 out of 6 or 1. If you think about this, it actually makes a lot of sense, because a complement is just something not happening. So let's think about an example of, is it going to rain tomorrow? Well, the probability of it raining tomorrow, so the probability of rain, let's say there is a 3 out of 10 chance it's going to rain tomorrow. Well, the complement of its raining would be the probability of it not raining. And if you think about it, if 3 out of 10 times it rains, what happens for the other 7 out of 10 times? Well, if it doesn't rain, it's not raining. So the probability of it not raining would be 7 out of 10. 3 times out of 10 it rains, the other 7 times it's not raining. And notice I add these two together, I would get 10 out of 10 times, which makes sense because it either rains or it doesn't, which would just be 1. The complement of something is just when it doesn't happen, and the complement event and the original event always add up to 1. Their probabilities always add up to 1. And we can use this to make some problems a little bit easier for us. So if we look here, we've got a bowl contains 5 red chips, and if you notice, I'm going to underline important information. 7 blue chips, 6 yellow chips, and 10 green chips. 1 chip is randomly drawn, find the probability. Well, got to remember, probability is always what I want over what I can get. Which means, first of all, I need to find out what I can get. What is the sample space? Well, I've got a bowl with all these chips in it. How many chips do I have? Well, I've got 5 red chips, plus my 7 blue chips, plus my 6 yellow chips, plus my 10 green chips. When I add these all together, I get 28. So there are 28 different chips that I can get. This is my sample space. Now, it makes these problems pretty easy. What's the probability of getting a blue? Well, I can get 28. What do I want though? I want a blue one, and there are 7 blue chips. Which means the probability of getting a blue is 7 out of 28, and this fraction can be reduced if I divide each of these by 7, and it reduces to 1/4. So what's the probability of getting a blue chip? 1 out of 4. What about for red or yellow? What's the probability of getting red or yellow? And if you notice, I sometimes put something in parentheses. I'm just putting what I'm finding the probability of. So P of ROY, P probability of red or yellow. So what can I get? Well, there's 28 chips in the bowl. Now, what's the probability of red or yellow? This means I can have either one. Well, there are 5 red ones, 6 yellow ones. So I'd have 5 plus 6. Or I could just say 11 out of 28. And that fraction does not reduce. So what's the probability of getting red or yellow? 11 out of 28. And now, here's in part C, here's where using a complement can really help us. What's the probability of having not a green chip? Well, there's 2 ways to do this. You could, so the probability of not green. Well, I could say, okay, there's 10 green ones, so there's 5 red, 7 blue, 6 yellow, add those all up. Which isn't too bad in this case, but what if there were 10 different colors or 20 different colors? That would take a lot of work. instead of adding up 5 plus 7 plus 6, what I can do is I can say, I know there are 28 total chips. And I know 10 of them are green. So if I subtract the 10 green ones out of those 28, and notice there's 28 out of 28 of the chips, 10 out of 28 of them are green, which means, notice I can subtract these fractions because they have a common denominator, that 18 out of 28 of them are not green. We just found the complement of the green chips. That's the probability of them not being green. I just subtract out the probability of getting a green from all of the chips. So I have 18 out of 28 is the probability of not getting a green. Again, you could have added up these three, which if you do 5 plus 7 plus 6, you do get 18. Or you can just subtract this 10 green chips from the 28 and then always reduce your fraction. It would reduce to 9 over 14. Our probability of getting a not green chip is 9 out of 14.